All right, everyone, we are just about through this trigonometry unit. We're going to tie this all off by talking about the law of cosine. So similar to the law of sines, we can use this to find the measure of any given triangle, not just the right triangle. So we're going to use this law of cosines, and I'm going to highlight again these sides and angles. So I have A, side A, which is opposite to angle A. I have side B, which is opposite to angle B. And I have side C, which is opposite to angle C. So now, unlike the law of sines, that was one given ratio, the law of cosines is actually three different equations or systems that we can use to solve for any missing side or angle. And the first one is if we're trying to find something to do with A, whether it's angle A or side A, we'll want to use A squared. A squared equals B squared plus C squared minus 2BC cosine A. Now I know that looks like a lot, but thankfully these equations are all going to be very, very similar. If we're trying to find the side A, that means we have to be using the cosine of A. So the angles are going to match the side we're using. And in between here, we just have the combination that would be the same sides, these sides that we're not trying to solve for in either the side or angle. So B squared, C squared, and then B and C both multiplied by 2 cosine A. Similarly, we would say that for side B, we would have B squared equals A squared plus C squared minus 2AC cosine of B. So again, if we're trying to find side B or angle B, we would be using those other sides as plugged into their value places. And then same thing, C squared equals A squared plus B squared minus 2AB cosine of C. Like I said, this might seem like a lot to memorize, but we'll be talking about where we get these equations from to hopefully help you understand a little bit more about where we get these equations from and make it a little bit easier to remember what they would be. So let's go through an example of trying to find a missing side. So let's go through example number 1 here. We want to use the law of cosine and round to the nearest tenth. So I am given 7, 12, and the angle 65. Now it doesn't really matter which equation we use up here as long as I am keeping the sides and angles in check. So since we're trying to find a side, it doesn't really matter which equation we use. We're just going to have x squared, and that's equal to my two other sides, 7 squared plus 12 squared, minus 2 times 7 times 12, and then the cosine of the angle, since it's the opposite one there, 65. Well, the nice thing is that I can do a lot of simplifying right here. X squared equals 7 squared would be 49 plus 12 squared, which would be 140. So now when you take those two, add them together, you would get 195. So we have 195 minus 2 times 7 times 12 cosine of 65. And I can also multiply 2, 7, and 12 all together. X squared equals, well, 7 times 12 would give me 84. And then multiply that by 2, I have 195 minus 168 cosine of 65. Now, thanks to our handy calculators that we have, we can actually take and plug in this right-hand side. So I would have x squared equals a number. And so I'm just going to type it in just as it appears. 195 minus 168 times cosine of 65. And I get 124. Since we want to round to the nearest tenth, doesn't really matter what this decimal is going to be. And now I can take the square root of this because I have x squared and I want just one x. So I'm going to take the square root of both sides. And so x equals, well, we can use that trick we learned last time of second square root, second answer. And we get 11.1355. Well, we want to round to the tenths, and that would leave us with 11.1. So that's how you would find a missing side. Next, let's take a look at how to find a missing angle example. All right, so if we're taking a look at a missing angle example, it really helps us to be able to highlight which of these sides and angles go with each other. That way we're keeping track of what we're using. So if I'm trying to find angle X right here, that means that it is opposite of angle 21. So for my equation, I know that I need to have 21 squared equal my equation. Because since that is the opposite side, our law of cosines said that the opposite side to the angle I have is the one that goes on the left side of my equation. So we have 21 squared equals my two other sides squared, 16 plus 26, both squared, and then minus 2 times my other two sides, 16 and 26, and then cosine of my angle X. Again, we can do a lot of our squaring first for this problem. So let's do that to get things in a little bit more of a simplified way. So first we have 21 squared, which would give us 441. And that equals 256 for 16 squared and 676 for 26 squared. I can also do my multiplication of 2, 16, and 26 to get 832 cosine X. Well, I can combine these like constant terms on this side before I move them over. So let's do that. 256 plus 676 would give me 932 minus 832 cosine of X. Now, like I said before, we want to get our like terms on the same side. So I'm going to minus 932 from both sides of my equation, which will give me negative 491 equals negative 832 cosine of X. Well, if I'm trying to solve for X, I need to get this to just be cosine of X. So I need to divide both sides by 832, negative 832. And that will give me 0.5901 equals cosine of X. Now we're to the point that we've talked about in the past where we're trying to solve for X, but it's inside of a function, and our trig is just functions. So that means that I can take the inverse of this function on both sides of my equation. So I get X equals cosine inverse of 0.5901. And when I use that in my calculator, again, here we are going to do second inverse of cosine, 0.5901. And we get that X should equal 53.8 degrees. again, it's all about knowing which angle we are trying to solve for, which one we are trying to find, and what we are given as information other than that. If you have any questions, please send me an email. Let me know what your questions are. I'm always happy to help. See you next time.